Welcome to Vision Plus and welcome back to this S.4 Mathematics. We are looking at finding the gradient of a curve at a given point. Example 5 says, part A, find the gradient of a curve, and the curve is y equals to open bracket x squared minus 1 close open x plus 2 at the point when x equals to 2. Now, for us to get the gradient of the curve at a given point, we first need to get the gradient function of the curve. But if you look at this curve here, we cannot differentiate it straight away. We need to expand. So y becomes, let us expand the two brackets. X squared times x, that is x cubed. X squared times 2, that is 2x squared. Negative 1 times x, that is negative x. Negative 1 times 2, that is negative 2. So this is the expanded form of the curve. Now let us differentiate the curve so that we get the gradient function. Therefore, dy dx becomes, if we differentiate x cubed, we get 3x squared. When we differentiate 2x squared, it gives us 4x. When we differentiate x, it gives us 1. When we differentiate 2, it gives us 0. Okay? It gives us 0. So this is the gradient function of the curve. Let me confirm if it is correct. X times x, x cubed plus 2x squared minus x minus 2. Yes, so this is the gradient function of the curve. This is a function that defines for us what the gradient of a curve would be at a given point. So now in this case, we have a point when x is 2. This information is enough because the gradient function is defined only in terms of x. So therefore, when x, my handwriting is going, when x equals to 2, therefore our gradient when x equals to 2, you can just write x equals to 2 becomes, you come and substitute for x as 2. That gives us 3 times x, which is now 2 by the square, plus 4 times x, which is 2 minus 1. This is going to be 12. 16 minus 1, that is 15. Me, I'm getting 15. It's not even 15. It's like 17 there. 2 squared times 3. 2 squared times 3, 12. Let me simplify. So I have 12 plus 8 minus 1. Yes, plus 8 minus 1. 19. Okay, it is 19. That's why it is good to press the calculator. Don't rely on your own mathematical examination. So therefore, the gradient of this curve at that given point is 19. Let me verify. 12 here. Here we shall have 8. 12 plus 8, 20 minus 1, 19. So that is the solution for part A. In the same sense, we need to go to part D, applying the same principles and approaches. So part B says find the gradient of a curve defined by y equals to 5x cubed minus 7x squared plus 3x plus 1 at the point 0 and 3. So we need to get the gradient function of the curve so that we can go on to find the gradient. So dy dx becomes, if we differentiate 5x cubed, we get 15x squared, and you know that how we get the answer. Minus, if we differentiate 7x squared, it gives us 14x. Plus, if we differentiate 3x, it gives us 3. Plus, if we differentiate 1, which is a constant, is 0. So this is the gradient function of the curve. The purpose of the gradient function is that it tells us what the gradient of the curve at a given point is. Now at this point, at the point 0 and 3. What is the gradient of the curve? You can say dy dx at the point 0 and 3. 0 and 3 equals to, then we substitute, this is x, this is y. So we only substitute for x because the gradient function will always be independent of y. There is no term in the gradient function that contains y. So that here we have 15, x is 0, but square, minus 14, x is 0, plus 3. This here gives us 0 minus 0, plus 3. Therefore, the gradient of this curve at the point 0 and 3 is 3. So, therefore, our gradient is 3. That is the solution to part B, and this is the solution to example 5. We have come to the end of finding the gradient of a curve when we are given a point.